In this video, we'll look at why context is not RAG. One of the most common answers people give when you ask how AI should understand a codebase is simple. Just use RAG, Retrieval-Augmented Generation. And to be clear, RAG is incredibly useful. It's one of the main techniques that make modern AI applications possible. But there's an important distinction that often gets lost. Retrieval is not the same thing as context. Let's start with what RAG is designed to do. In a typical RAG pipeline, you take a set of documents, source files, knowledge base entries, and you convert them into vector embeddings. These embeddings are stored in a vector database. When a developer asks a question, when an agent needs information, the system performs a similarity search against those embeddings to retrieve the most relevant pieces of content. These retrieved chunks are then inserted into the model's prompt so the model can use them while generating its response. So the model effectively sees something like a user query, a few retrieved documents or code snippets, and instructions for how to respond. That's the essence of RAG. It's extremely effective when the problem is information retrieval. For example, what does this API endpoint do? How do I configure this library? Where is this function defined? But software systems are not just collections of documents, they're systems of relationships. And this is where RAG breaks down. In large codebases, the most important information often isn't contained in a single file. It exists in the relationships between components. For example, which service depends on which other service? Which API is considered a stable contract? Which component owns a particular data model? Which dependencies are safe to upgrade? These relationships are rarely expressed in a single document. They exist in architecture diagrams, dependency graphs, build systems, CI pipelines, and operational conventions that have evolved over time. When a model uses RAG, it retrieves pieces of text that look similar to the query. But similarity search does not reconstruct those relationships. It retrieves fragments. Imagine asking an AI agent to modify a service. With RAG, the agent might retrieve the source file being edited, a related test file, and a README describing the service. But what it may not retrieve are the structural constraints that determine whether the change is safe. For example, which downstream services depend on that interface, whether the change violates an architectural boundary, whether the change introduces a circular dependency, whether it breaks a contract used by another team. Those are not retrieval problems, they're graph problems. They require understanding the topology of the system. This is where context becomes fundamentally different from retrieval. Context means having a structured representation of the system, a model of services and their relationships, dependency graphs, APIs and contracts, ownership boundaries, coding standards and policies. Instead of retrieving text fragments, the AI can query that structure. It can ask questions like, what systems depend on this service? Is this change compatible with the current API contract? Does this modification violate architectural policy? Those are reasoning tasks that depend on structured knowledge, not just retrieved text. You can think of RAG as giving the model access to a library. The model can search through documents, pull out passages that look relevant, but context infrastructure is more like giving the model a map of the entire system. It understands how things connect, and that makes a huge difference when you're making changes to a complex environment. So why does this matter for AI development? As AI coding tools evolve from autocomplete to fully autonomous agents capable of making real changes, this distinction becomes critical. Agents are not just answering questions anymore, they're modifying systems. And modifying systems safely requires understanding how those systems are structured. That's why the next phase of AI development won't be defined by better retrieval pipelines. It will be defined by context infrastructure that allows AI systems to understand the relationships inside the environments they operate in. Because ultimately, reliable AI development isn't about giving the model more information, it's about giving it the right structure to reason with. Learn more at tab9.com.